3 years after Log4Shell caused a major security issue, we are still struggling with insecure dependencies and injection problems. In this podcast, we'll discuss how developers can secure their code.
Welcome to the Foojay Podcast, all your news about OpenJDK.
In this episode of the Foojay Podcast, I talk with 3 authors who published a blog post about security and code quality on Foojay. These are my guests.
My name is Vermeer, and I am a developer advocate or staff developer advocate and engineer for Snyk. Snyk is a security company which is based all over the world, but is also active in the Java ecosystem, with me being most actively in the Java ecosystem. I am a Java champion, Oracle Ace. I've been around for a long time as a full-time engineer, and now in my role as a developer advocate within Snyk.
Hello, I'm Jonathan Vila, and I work as a developer advocate for Sonar Source, that it is the company behind products or famous products like Sonar Cube. I'm also part of the Java community in Barcelona and one of the founders of DevBCN.
I'm Erik Costlow. I've been in Java for over a decade now and application security for even longer than that. My absolute expertise is really the union of Java and application security, because if we're one of the most popular languages, we better do that safely.
Let's start with Brian about his article, The Persistent Threat Why Major Vulnerabilities like Log4Shell and Spring4Shell Remain Significant. I asked him what the problem is with insecure libraries.
Well, the problem is that we probably all know about Log4Shell. Let's keep that one. That was the biggest one of the two. And that was a major vulnerability that was, I think, from top of my head, disclosed or at least published December 10th in 2021. I mean, we're now in 2024. But what we found out is that there is still a significant amount of applications around that are using these vulnerable dependencies, like this vulnerable Log4j library, and they're still out. At least we don't know how much is really deployed, but we can see that the code is out. The code is still available either on GitHub or with our own customers or something like that. And still people are using old versions of these libraries, which I don't have to remind, hopefully I don't have to remind people how significant that threat is, because Log4Shell hit the news as a CVSS score 10 major vulnerability when it was easy to inject code. However, we will see that if this one, which is a top vulnerability, which hit the national and international news, is still surfacing because people are still using the old libraries, what happens to the ones that are not a 10 but a 9 or an 8 or a 7? That's scary. So that's why I was looking for it, as in, hey, how many applications are still using this? And yeah, that was interesting.
I think you can also see that in the number of downloads in the Maven repository. So they also have charts about which version is getting downloaded. And so that means that there are still builds running every day on a system, pulling in these old, outdated versions with vulnerabilities.
Yep.
So that's the biggest issue.
Part of these builds are mine because I still demo these things, obviously. So yes, but it's not thousands. Like maybe a couple of builds a week are mine, as in I'm still maintaining vulnerable applications for the reason of demoing. Yeah. So just want to say it will never be completely zero.
Yeah.
But the amount now is insane.
So if we go down to a few per month, then it's you, and then we know it's fixed.
Probably it's me and my colleagues, or somebody in like in other security trainings and that kind of stuff to use it as awareness pieces. But yeah, if it's down to a couple of hits per month, then we're fine.
Who is responsible? Is it the developer thing? Should we as developer fix this?
That's an interesting question. I don't think we can put the responsibility on a single person or a single group. Let's face it, like we've all worked in companies and as part of a larger engineering team or something like that. And it's also like, where are the priorities? So yes, as a developer, you have a significant input in that. But don't get me wrong, I've been in companies where there were product managers and C-level managers and breathing down your neck to get that new feature out. And if they say like, well, it's not that important, or don't see the threat in that because we think it's only internally facing or something like that, yeah, then still it remains. If we downplay the significance of such a problem, then that's one thing why it happens. So it's not just to blame a developer. Absolutely not. We all know how we need to work under stress, as in we need to get this feature out today, right? Secondly, I am not sure if some things are even maintained. I like if you work in a very conservative company, is it even possible to upgrade to a newer version of Log4j in this case, or in this case, the other one was Spring for Shell, so the Spring one, which was less significant but still significant enough. If you're still on an old stack and that thing is running in production, it can be hard to update to the newer version because that breaks API. That means your whole stack needs to be rebuilt with newer versions. So it can be that it's either pretty impossible and people don't want to do it. It's impossible that they don't have capacity. It's possible that there is no priority for that. I think it's a more of a cultural and company-wide aspect.
Yeah. But you have to go back to your sources, update dependencies, build it again. So you really have to go back to the build process to be able to fix this.
Yes, yes, and I think I think the other thing that we see over here, that if it's outdated or you're using an outdated version, how outdated is it? So that means, are you doing any maintenance on an application that is in production? Which begs the question, like, how do you work with that in general? Because then you're not only having a security problem, but you have a maintenance problem in general. Because if your version of whatever is like 5 major versions behind, and something happens like this one, it's impossible to just update. That means you have to rewrite probably half of your applications because everything changed. Yeah. So it connects to a lot of stuff that we hold dear in software engineering. But yeah, this faced my eye, or this I caught this one, and I thought it was interesting to write about it after like almost 4 years, or almost 3 years. Sorry.
Yeah, 3 years. So it's 3 years for Log4Shell. It's 2 years for Spring for Shell. So indeed, they're still there.
Yep.
You're working for Snyk. I guess as you write these articles, I guess you also have a solution or a way to help people with this kind of problems.
Obviously, we have a solution. As in, we do have products that and free products. Don't get me wrong, to help you out with scanning your dependencies and even knowing that something is vulnerable, and if there is an updated version that fixes that particular vulnerability. And why I say that particular vulnerability, because it depends obviously on your use case how important a vulnerability is. Some lower or medium level vulnerabilities you might be okay with, depending on what the service of your application is. However, this one, the thing is, we can point out for a vulnerability, hey, you have that in a certain library, and you can update it to a new library. Or if it's part of a bigger dependency, say it's a transitive dependency as part of a Spring Boot starter or something like that, you can update to a newer Spring Boot starter or any top-level dependency that encapsulates that problematic dependency, like that Log4j library. So we try to help people with that. Also, if you connect to our systems, we can help you by updating it to newer versions, even if it's not a security problem. So say there's a newer version of a JSON library or an XML parser or something like that. There's a newer version out. We can help you with updating it to newer versions. If you connect it to your Git repository, for instance, we can create pull requests. So you are up to speed. And if something problematic happens, it's not such a big impact. Like the delta between where you are and where the newer version with the fix is is quite small in that case. So yeah, that is things that we can do. However, we cannot help if you are like, no, it's not a problem. If it still works, don't fix it. We can only point the problems out, and it's up to an individual or an individual company to actually do the fixes.
Is that also a bit what Dependabot in GitHub is doing? So automatically they are alerting you for certain security related. Yeah.
Dependabot does a similar thing. I will not go into product details and comparison, but yes, if you are on GitHub and you have Dependabot, Dependabot helps you already a bit to update it to newer versions when there are problems, and even if there are newer versions available. But again, if you already have something, like what are the problems? How can you fix it? If what if there is no newer top level problem? Say there is no new Spring starter for you, but you have a problem underneath. To what minor version of Log4j or whatever library can I update manually by overwriting it in my Gradle or Maven POM file? Like, we give you that information. But yeah, Dependabot does a similar thing on the dependency updating.
But yeah, all these tools alert you if a vulnerability happens. True. But if you wait for a vulnerability, you can indeed get very outdated dependencies. And that's probably, I think, for a lot of developers, companies, a big problem, because spending time on only updating dependencies and updating your code because you're updating, that doesn't bring a lot of value immediately.
No, that's true. It doesn't bring a lot of value immediately, but we have to pick it from two sides, I guess. One of the things is, yes, we have to do this. Like, it's part of a routine. If you buy a car, it needs annual checking, and in some countries we have like, it needs to be annual check to make sure that even is allowed to drive on the road. If you buy a property, if you buy a house, it needs maintenance to make sure that it doesn't collapse, but also that you're insured. Like, if you just lack the maintenance, your insurance will say, yeah, that's on you. Why aren't we doing the same with software? Like, why do we think this is a burden? It's something that we serve to our customers. So we need to put maintenance in, and we need to take time for that. Secondly, we can automate a bunch of stuff of that by the tools that we just discussed on, to see what kind of problems are there surfacing. And for instance, we can already give you a pull requests on updates, like, hey, this is there. You just have to click OK. And I assume that you have a test suite. So that's another thing. Like, if you have a extensive test suite, you can already test the pull request to see if it is a problem, if a newer version comes in. And if it is, it's just a small fix. If we wait, the fix will get bigger. Just like if I have a leaking roof here and I will just leave it, it will only get bigger. So it's a mindset. But also, there are enough tools available to help you automate half of it, so that you don't have to manually search for these kind of things, or like, put your mind to it. As in, if a tool pings you, there's a new version, they're like, okay, we need to take care of that. And at least you can put it on your Jira board or whatever board with a certain priority. But then it's up to you how you prioritize that. Same as maintenance to your car, your house, or anything that you own.
I like the comparison. That's not how many people look at software, but it needs maintenance.
It needs maintenance. And what we see if we generally go into software is that we build something as a proof of concept, very small, and then we build things on top of that. Can you imagine that we do that with a building, with an actual structure? That is insane, because then we say that the foundation is not built for this. But for software, we do exactly the same. So we just connect bits and pieces to each other, and no wonder things go wrong, or we don't know anymore what the intention was of certain code. So we have a bigger problem in software engineering, I guess.
And maybe that's maybe a good responsibility for developers. One of the biggest advantages of the Java system is all these libraries which are available, but then, and I've made the same mistake, you end up with projects where you have 3 different dependencies all helping you with XML. because you found some example code and this dependency, you just smash it all together. But reducing the amount of dependencies, and then also maybe looking into evolutions within Java itself, at some point also removing some need for dependencies, that's also a responsibility for developers, I guess.
Absolutely. Like, do we need that third or fourth XML parser while there is an XML parser already in Java? Like, and you see that because there's pressure on developers in enterprise. Like let's talk about enterprise development. There's pressure on developers to get that new feature out. I understand. Like, we need to get it fast and it needs to work because my manager doesn't know how it works and he just wants to see results. Yes, I'm downplaying it now a bit, but you know what I'm saying. So
Absolutely.
okay, who cares if I put that another dependency in? Well, in the end, for the maintenance of stuff, it does it does matter. Also, like, do you have dependencies in that are still there and that are still packaged in your artifact that you're not even using anymore? And hopefully most people know that, but things like Maven and Gradle have plugins to check if a dependency is used or not, if it's declared but not used. And even I know at least in Maven and both in Gradle is there's also a plugin, but we can already check if there are newer versions available on Maven Central of a newer version. So you don't even need a tool. You can do it just with your package manager. And these things are already available, but you have to build that into your routine or into your build pipeline or whatever you want to do it. But yeah, dependencies that are not used or dependencies that are there multiple times or similar dependencies that are there, that's definitely a problem. We have to clean our house up. I mean, I know my office is a little bit of a mess, but guess what? If my wife comes in, like, come on, you need to clean this. Just like back in the days when my mother was looking at my bathroom, like, Brian, you need to clean it up. That's also happening. It's the same for software. Clean your stuff up. Like, do we actually need it? Do we need to pull a new dependency in? Do we already have something that is there?
Very nice message to conclude. Another question. I see you're wearing a sweater of the NL Jack.
Yes.
Are you ready for JFall?
Almost. As in, we just finished. As in, a week ago, we had the program committee meeting about which talks we're going to pick. Just to give you an example, like, we had over 450 submissions, and we have about 55 available spaces. If I just take all types of talks in accordingly. So that was a hard thing to do. We're almost done with the schedule. So yeah, everything is going according to plan. We're not there yet, but we still have some time left. It's November 7th.
Yeah.
It's in November. November 7th, and like, everything going according to plan, and we already invited the speakers that we want to have.
And we will be there with a small team of Foojay to also have some interviews again live on the conference floor, so that we can talk to the Java community and see what questions there are, what people want to know, what people want to learn, so that we can maybe generate some new content also for the website. Okay, thanks a lot. Is there something more you want to add?
No, I want to ask everybody to keep an eye on Foojay. I mean, it's amazing that Foojay is there for about 5 years now, if I'm not mistaken.
Yeah, probably.
Maybe even longer. And every day there are new articles, and some might overlap. But, like, if you can see the amount of content that is created from all over the world that is aggregated into Foojay, I think it's an amazing platform for everybody that is either starting in Java, but also who are seasoned developers. There's always something that you can pick and read and stay on top of. So I just want to thank you for the initiative, for you and the rest of the Foojay team, and keep doing this. I think it's amazing.
And thank you for your articles, because we wouldn't be there without all the authors that are writing and sharing their content, which is also a call to other people who have something written on their own blog, on the company blog, which is Java-related, GVM-related, Kotlin. They can all share it on Foojay. Okay. Jonathan Villa's article, Top Security Flows Hiding in Your Code Right Now and How to Fix Them, about various injection problems, made me wonder if SQL injection is really still a problem.
It's not long enough. I mean, that there have been issues on related to SQL or no SQL injections. Uh, there has been issues on MongoDB databases, even in the famous game Fortnite. So they had a breach in 2019. But the thing is, you could say, well, it's 2019, right? So we are in 2024. But we need to think that there are applications already running, created years ago. They are not patched. And we are even creating applications without having these issues in mind. And if we check how many applications have been created following the proof of concept trapped, where you create a proof of concept, because we are going to create this POC and then trash it. But then that POC becomes a production thing months later. And you didn't put a lot of effort on thinking about these vulnerabilities or injections. And now it's in production and you are not using parameterized statements, and you are using concatenated strings because that was faster. I don't know. But then you suffer from and easy to write. Yes. Yes.
So the main problem is if you just accept any string input from a text field or whatever and use that in your query, then you could have some smart guys or women making some very funny inputs that actually breaks your database. Yeah. But, yeah. You gave an example with Tesla. They also had an issue like that.
Yeah, with it was in 2018 related to the Kubernetes console. Apparently, there was some SQL injections at that time, and attackers had even permissions in order to run things, applications on those clusters. They use that power to run crypto mining applications. So a lot of power were invested on.
And they earned some money. So and it's a hard problem to solve on the server side. Within your infrastructure, you cannot solve this really because if it's in your code that you're creating these queries and they are reaching the database, there's not much you can do there except changing the code again.
It all depends how you define your infrastructure. I would say I've seen ways of solving or mitigating the log4shell vulnerability without touching the application code, just because they were using service mesh. If you are using applications that are controlling the networking between your applications, in this case with Istio or Envoy proxies, then you can introduce filters that can sanitize somehow those inputs from the user. Definitely, this is a way of mitigating the problem, but I would say the best way would be to fix the applications. But I would go even further, that it is the main goal of this article is not about teaching you how you can modify your current applications. Yes, that's one side of the article, but it's just making you aware that there are those injections problems and that it's easy to prevent them, investing few seconds or even using tooling that can help you in order to prevent those. those issues.
So in the article, it's not only about SQL injection. You also mentioned deserialization injection. Oof, that's a difficult word.
Yeah.
What's the problem there?
Yeah, well, basically, if we are using any deserialization mechanism, that means we have a Java object. We convert it into a byte stream. Then we send it through the network to a server that will take that byte stream, and we will create a Java class, Java object from that stream. Because this is a way of sending information, okay? Usually, you expect that the class that you are going to receive is the one that you are expecting. Who is going to send an unauthorized class, right? Sometimes we rely on the front-end checks. So, okay, if the client side is doing their thing, so I have a client connected to my RESTful application backend, and yeah, I expect that some checks are made in the front end. But what happens if someone connects directly to our backend application and sends something that it is not accepted? Well, in my example, the thing is, you send a wrong class, a wrong object, and everything happens as it expected. Yes, the backend says this is a wrong class. I cannot handle this request. Fine, this is the expected output. But before saying that, there are some things that are happening, that are being executed, that can harm our system, and people can just simply, I don't know, remove files, create files, even open the calculator. This is a usual example. Just because they are sending an object that has been serialized containing some methods that will be executed before trying to do the typecast.
Yep.
So, yeah.
And is that then the same thing which also happens with logging injection? Something gets logged and is able to execute something?
Well, with the logging injection, what we can suffer from is, well, two different things. One is that the user can send information along with the data that they know this information is going to appear in our logs. And then it will make us way more difficult to find which is the problem. Or even it can introduce some information that, can make the person that is reviewing the logs to be puzzled somehow. That's called log forging. That, well, they are creating information that they know it will appear in the log. But also what we can have is remote execution. So, for instance, with the famous log4shell vulnerability, they are using, in this case, LDAP in order to do lookups. And before the patch in Log4j, this feature was enabled by default, so people could just simply add a text in the user that they are typing in the front end, and then Log4j is going to try to execute that code, and then they can introduce some bad code in our system. There are ways of preventing this, especially updating to the latest versions, obviously. Also disabling lookups, that it is something that it is by default in the newer versions. But it could be that in some cases, we still need lookups. In all the cases, we need sanitizing. That's important part.
What I also always have learned is in logging, you should never log any kind of sensitive or personal information, like even logging an email address of someone who is signing in is already considered. It's not an injection, but it's not safe or
Yes,
not complying with what you should do with personal data.
you are totally
Yeah.
right. Depending on the laws, but yeah, definitely, you never know who has access to that log files. Sometimes we don't think there is any special information in the log files, so we don't put extra effort on protecting those log files. But it could be that
Mhm.
someone is logging user and password.
Yeah.
It could be that they are logging, I don't know, tokens.
Mhm.
That if someone has access to those log files, then they have the keys to enter the system. Yeah.
I have to admit, I have definitely logged passwords at some point because I wanted to be sure that my form arrives at the server and the information is correctly parsed. So, yeah, it is definitely something to think about. What do we put in the logs? I even read a Twitter or a Mastodon message that you should add sometimes in a field the Y with two dots on it because that ASCII code is 255, so that appears in your logs as FF. So you can really annoy developers if you use some certain characters and do stuff
Yeah.
like that.
Yeah, exactly.
Hmm.
Um, we are putting the focus on, yes, I did this error before. Yes, you need to put attention on it. Um, but we are experienced developers and we are still sometimes failing because we create a POC, we don't put effort. Someone takes that, someone evolves that, and the first goal was not to be a production ready application. Therefore, you didn't put
Hmm.
extra effort, but in the end, it becomes
Hmm.
a production application. So it could be that even the most experienced developers sometimes introduce issues just because
Hmm.
they did not expect that that was going to production. Even the case that you were mentioning, I log passwords. You didn't do that on permanent status. So what you wanted is to debug
Yeah.
something, fix it, and then remove that debug line. Sometimes we forget about removing the debug line. So that's why we need some kind of tools that can warn us if we are introducing some of those issues that can easily skip our mind whenever
Mhm.
we are putting the code into the repository.
Yeah. Don't you become a senior developer by making mistakes? If you earn
Definitely.
if you earn enough mistakes, then you become a senior developer. And
I don't see any other way of becoming a senior developer. Yeah,
and if you break the production system, then that's even a bigger point.
yeah, definitely. Yeah,
Um, we talked earlier in the podcast 46 at JCon. I interviewed you there. You
yeah.
were talking there about Java communities and your work at Sonar. Um, Sonar is a code validation tool that you can use in IntelliJ, correct? Can this tool warn us for errors like this?
Yeah, so Sonar has like a set of applications. One of them is, as you mentioned, the linter, so the IDE plugin that can connect to SonarQube. That is
Mm.
probably the most known tool for this. That will analyze your code and will check for issues regarding errors, vulnerabilities, even design or bad design patterns, or a lot of stuff. And SonarLint is the tool that will run in the IDE that will check these issues and will warn you that, hey, you need to fix this and not use lookups
Mhm.
in the logging, or you should not use a string concatenation in when you are creating queries. Or if you are deserializing objects, it will warn you also about it. So it's SonarLint is one of those tools. There are others. Obviously, I'm a bit biased because, uh, but definitely having this kind of tools in our IDE that can prevent us from committing bad code will save us a lot of problems and a lot of work.
Mhm.
Sometimes I've seen when do you fix your tech debt or your issues? Well, we create uh, a sprint for that. That's not the good approach.
Mhm. Mhm.
It's hardly uh, to be a reality in some cases. So you postpone and postpone it. So the best way is to fix it before committing the code.
Mhm. Mhm. And that's what you want to achieve with your article, is that developers are aware of these issues when they are writing SQL
Exactly.
queries, for instance. Yeah.
Exactly. So basically, it's about, as I said, these kind of tools not only warn us about uh, issues or vulnerabilities. These kind of tools can also help us a lot. In the case in my article about Java 21, there are some things, some features that we don't know about Java 21, that we don't know about Java 22, 23. Um, so it's important to have something that will analyze our code and will say, hey, there's a new API in Java 21 that can help you to do this in a better way, in a more consistent way. So we need to take advantage of those tools. In this case, for Java 21, and also that's the other article about the top issues. In that case, from Sonarlint, we collect a lot of information, telemetry, and we know which are the top issues that happen in open source projects. And sometimes we don't think that can be possible, but one of the most common security issues in the projects being analyzed is hard coding passwords. It was hard for me to believe that
Mhm.
when I saw it, but yeah, it's thousands of instances of this issue happening in all the projects being analyzed by, in this case, Sonarlint. It's incredible, but yes, it is what it is. So I think we have an ideal idea of what the code should be, but the reality is way different. And yeah, there are lots of issues, not very complicated. If I have a talk talking about those issues, and when I ask people about those issues, people say, "Yes, it's obvious. You shouldn't hard code passwords." Yeah, but this
But it still
happens.
happens. Yeah. And then we luckily have the tools to warn us about that. I think, like for instance, GitHub projects, it also, if you commit something like that, a password, and it recognizes it, it will alert you. Huh?
Yes, exactly. GitHub also has the SQL, the security. Remember exactly the name.
Mhm.
CodeQL is the technology behind it, and it will also check our code uh, or certain
Mhm.
rules in order to warn us, "Hey, you shouldn't do this."
Yeah.
Yeah, there are lots of tools out there, but we need to think about uh, having one. If it can be Sonar, it's it's better. It's not only that I am biased working at Sonar, but also that well, those tools have long time experience. So they have been in the market for more than 15 years now, and we have lots of rules. Even well,
Mhm.
for more than 30 languages, and yeah, the coverage is huge.
Mhm.
So, but in any case, using a tool that can check our code, it's definitely the
Yeah.
best thing that we can do.
Okay. Good. Okay. Thank you. Thanks for the great article. Of course, the
Thank
link
you
will
very
be in
much.
the show notes. I didn't think we would ever talk about pandas in this podcast, but that's exactly the topic of the article by Erik Costlow. He discovered that trash pandas love enterprise Java garbage code, and those trash pandas seem to be attracted by unused code.
Yeah, I just think it's fun to have a topic. Everyone takes security so seriously that they kind of lose sight of what they're doing. And I think if we just inject some fun into it, we can get better results and also enjoy what we're doing. So
Mhm.
trash pandas are it's a nickname for a raccoon. And since raccoons love hunting through the trash, and some of the times, let's face it, we refer to our code as trash. Let's just talk about stuff that we can throw away. So the joke of trash pandas, I really just thought it was funny.
Yeah, indeed. The article is really about unused codes. What's the problem with that part of our code?
Yeah, the article was about unused code and how, as engineers, we tend to write a lot of new things, but we never really throw anything away. So we leave a lot of that old legacy code in there, and we just go back and we kind of hoard it, and we say, "Well, I might need this function someday." Well, Trash Panda article is about the idea that instead of us going through and hoarding all that code, if you watch it and you realize, you know what, I don't use this method, you can throw that method away. It's possible to get rid of some old things. So for all these libraries and security problems that people have, where like there's a really old library and people just say, "Well, I have to update that library." What if you don't have to update it? What if you don't use it and you could just throw it away?
Mhm. So it's not only about the code that we write ourselves and becomes unused at some point. It's also that we are have a history in a lot of projects of old dependencies, outdated dependencies, maybe dependencies we don't use anymore.
Yeah, I mean, as engineers, we love to go out there and take advantage of other people's work. And I love to go out there and grab a library. If you have a function I want, if you have a feature I need, I'm going to go grab your library. Well, over time, as a lot of people work on applications and something's been around for 4, 5, maybe 10 years or more, different people who worked on the application have grabbed different functions. And I've seen situations where people have, 5 or 6 different ways of generating a PDF. I've seen things where there's multiple libraries in a project that do pretty much exactly the same thing, but in different ways. Well, if you go to look at the way that your application works, you don't need all of those older libraries. Oftentimes, you have a transitive dependency that comes in. You have different things that you added a while ago and you switched, but you never took the old libraries out. So those vulnerability scanners are looking at your code and they're saying, "Oh, you have an insecure library over here. You better fix that. You're bad." But if you actually look at the application, the library is never invoked. So instead of fixing it and patching up to the latest version, what if we removed the things we didn't need and then just didn't have to deal with them anymore?
Mhm. Is it an issue if I have a library which has a security flow and it's not invoked? Is that still a threat somehow?
I think it depends on people's risk tolerance. A lot of groups, the security teams are so stressed with the series of things that they have to look at that they just play this zero tolerance game and they say, if you have it, you're at risk. But I've seen other Java applications like MuleSoft, like some of the larger application servers. They had a lot of frameworks that people didn't actually invoke. So MuleSoft in particular ships with like 5 or 6 different versions of Spring. Well, when I go to deploy, I'm only going to use one of those. So a lot of these security scanners, they just go through and they look for what are the files that are there in that file system. You have, vulnerable jar 1.2.3. Or they look at the build chain and they say, over the course of your Maven or Gradle build, you bring in this version of Log4j that you're not supposed to have. Well, when you watch the application, it never actually runs. So is the risk real? Technically, yes, the risk is there and something new could always happen. But
Mhm.
a lot of these applications, you look and you say, are you actually using this code? There's no path to executing it. So the tools, I don't want to say they're wrong in saying that you're at risk, but the level of risk of concern is really low because there's no path to actually execute the vulnerability. And in fact, the code that it's contained in literally never runs at all.
Mhm. In the article, you mentioned something like you should treat unused and dead code similar to the garbage collector. So you let the GVM do the work. Is that a good idea from developer point of view?
Yeah, I mean, the whole point of Java, or one of the main points of it, is that it takes a lot of the work that people should have to do and it does it for them. It does automated memory management. I don't have to think about how I use objects as much because the JVM will clean things up for me. There's different ways that I could go through to hunt in my code and say, do I actually use this? I can run some coverage testers in a test environment that'll give me that data. I could instrument my code. I could throw logging statements everywhere. But why should I actually do that? Like, the JVM is able to know when a method is being invoked, and especially when it's being invoked for the first time. So why don't I just make the JVM tell me that information? If the
Mhm.
JVM tells me, I already have enough work on my cognitive plate. I don't want to have to go and figure out things that the JVM can just do for me.
Mhm. I know as a developer, as soon as I write a unit test to test a specific method, that method becomes used for my IDE. So it cannot
Yeah.
alert me again. Yeah, this is actually code which is not used within your application because it's used by a unit test. How do you fix this?
Yeah, so unit tests are really important, and I think they're really good. But we need to recognize that over time, technical debt builds up both in the code, in the requirements, in the way we think about it, and also in those unit tests that are designed to keep us safe from introducing breaking changes. So, what happens is over time, people write a piece of code and they do the right thing and they write a test. Later on, they stop using that code, but they never delete the test or the code. So you end up having a lot of unit tests that exist only for the purpose of making sure that the thing works the way it did a long time ago. There's no reevaluation to say, do we actually still need this unit test? So the way that we address that within the Azure JVM and Intelligence Cloud is we track what you run in a production environment and we track what you run in a test environment, and we give you the ability to see the difference. So what you can tell is, where am I spending time maintaining tests and worrying about green bars on things that I don't actually use? Because you can actually get rid of them.
Mhm. So you have these different levels of tests. So I also talked with Jonathan Vila about what he thinks is bad in code, like SQL injection. That's also something we as a developer should be aware of. But his tool, like Sonar, can alert you in the IDE you're doing something wrong here. There are also tools like Snyk, which run on the build server. Then we have Intelligence Cloud on the production system. Do we need all these levels of checks?
The level of check just depends on what you want to look at and where you want to see it. Like, it's always good to do things early, but over the course of looking at my code itself, I build up a simulated execution model. The benefit of like operating inside a production environment is you get to see the actual things that happen. So the way that different code combines via reflection, via like Google Guava, nobody actually, or very few people actually call into Google Guava. You just get a collection and it implements the collections interface so it shows up. So when you're watching in a production environment, if you look at the code level, there's no references to Guava, but when you actually watch the code execute, there it is. So it just gives you a different level of granularity. And then, the whole point of the DevOps being an infinity symbol is that there's information that comes back from the production environment. So that's what we're providing is, watch your production environment and bring a signal back so that you can take action on it.
Mhm. So actually testing in production. That's what you're aiming at.
It's not, I wouldn't really call it testing. I would just call it watching.
So that you have a real image, a real view on what's being used in production, how your system is behaving, and what code is being called, dependencies are being used.
Exactly. Like, is log4j a threat? Well, on paper, if I have that library, yes, it's a threat. But if I watch the application and it turns out I'm only using the API and I'm actually kicking it over to one of the other 8 logging frameworks via like SLF4j or something, there's all kinds of ways to rewrite and remap that.
With your system now being used in production, Do you already have results of how much code of some applications is not used?
Yeah, so over the course of watching a lot of applications execute, I can say if I show up to a room of Java engineers and pick anyone out of there, I'm going to see between 10 to 30% of their own code does not actually execute. And that's a pretty safe guess so that I know I'm going to be right because I don't like to bet. But if I go to watch an application and I pick one and I kind of get lucky, I've seen people go up to 50 or even two-thirds of a percent of their application just totally unused, where they can highlight it, hit the delete key, and it's all stuff that was written a long time ago. So imagine the thing that you work on every day, just realizing that you can get rid of two-thirds of that workload.
And how does this happen? Is it just historical? Applications get larger, the use case changes, developers come and go within a company?
There's a lot of ways. Developers come and go in a company. We write new things. There's a lot of causes of why we can say it happens or not. But what I think is that it's a lot easier to write code than it is to read code. So oftentimes we write a new function, we come up with a different way of handling some things, or we go and we create a new function to fix a bug and we just leave the old one lying around. It's just a level of maintenance where, we tend to keep the older thing around in case we need it. And we always say, I'll come back to delete that later. Well, later never shows up. So after, a couple years of an application being live, you have a ton of unused code.
Mhm. It's funny that you mentioned the readability of code because we just mentioned, talked about this in the Java 23 podcast. That's the goal of all the evolutions within the language, making the code more readable, and then also maybe moving some library functions into the Java code itself, making it also easier to read and to develop. Eh?
Yeah, I'm all in favor of legibility of code. The code that I write, I tend to spend time making it look clean. I love my IDE based formatters. I wish version control systems were format agnostic because I just want that code to look easy to read.
Mhm.
It makes working on it so much easier.
Yeah, and then being able to remove all the that unused code and making it smaller, that you only see the things that are really in use. That's also a big benefit, I guess.
Right. Imagine you go to read a book and one of the chapters has nothing to do with what the book is actually about. When you realize you don't need something, instead of leaving it around, you take it and you throw it away. I know it sounds scary, but it's still there in the version control repository. You can always get it back, but don't leave it just lying around to walk through every day.
Mhm. It's nice that you mention version control because that's also one of the guidelines. Never comment code. If you think it's not used anymore, then just delete it. You can still go back to your history in your repository. Huh?
When people delete code without really knowing, that I think is what gets people nervous about deleting code because some of the times that you're wrong. Some of the times, if I go and I say, I think this code is unused, there might not be any static references to that code. It could be something that's invoked dynamically. So if you just go in there and you say, I'm going to press the delete key and I'm going to see what happens, that's a really bad idea. Watching in production and getting a level of signal that says, no, this code never actually ran. It'll confirm for you, no, I never saw that code. It's safe to delete. So I would watch a little bit. I wouldn't just randomly take a guess and play Russian roulette with that delete key. Watch in production, get a signal. And after you watch a little bit, maybe you're suspicious about something. So you only need to watch for a week.
Thanks for all the advice, all the tips. Something you want to add still?
Really, it's just a matter of getting comfortable with the idea that you don't need all of your code. When I look at an application, like I said, it's an average 10 to 30% of someone's code is unused. Think about when you work on your application, never having to look at that code again. Never having to deal with a new security alert that comes in and says, this library is vulnerable. If you don't need things, if you aren't using them, instead of patching it, instead of doing maintenance on it, get rid of it.
As developers, we are responsible for the code and dependencies we use in our work. Keeping everything up to date and secure is a challenge. But luckily, we have the tips of these podcast guests and several tools we can use to keep an eye on what we write and run in production. Thanks Erik, Jonathan and Brian for your articles and joining the podcast. And thank you for listening. Keep an eye on Foojay for future articles and podcasts about development and everything related to the Java world. Thanks a lot.
Give me a Foo, give me a J, give me the friends of OpenJDK.